This is solving quadratic equations, solving by square roots notes. So when we're solving quadratic equations, there can be several different types of solutions. We can have one real solution. That's where the parabola will cross the x-axis at one point. We can have two real solutions, and that's where the parabola crosses the x-axis at 2 points. And we can have no real solutions where the parabola doesn't cross the x-axis at all. So if we have no real solutions, that means we can have possible imaginary solutions. Important to remember that not all quadratic equations have real number solutions. For example, if you have x squared is equal to -9, that has no real solution because a square of any number is never negative. However, if we have the square root of -1, we know that is equal to I, which is imaginary number. So in solving quadratics using square roots, we can only use this if there's only one x term. Very important. So if there's more than one x term, then we cannot use the square root method. It won't work. So if you see another x term there, then I would check first to see if you can combine like terms before you start using that square root method. The steps, number 1 is to isolate the squared term or terms. Step 2 is undo the square by using its inverse, which is the square root. And step 3 is to simplify the radical if needed. Okay, so looking at number 1, we first have to isolate our square. So I'm going to first subtract the 2 over. So I have 5x squared is equal to 80. Then I'm going to divide by 5. And checking 80 divided by 5 is 16. So I have x squared is equal to 16. Now that I have my x squared isolated, I'm going to get rid of that square by taking the square root of both sides. When I take the square root of something, that means I'm going to have two possible answers. So I have x is equal to plus minus the square root of 16 is 4. Meaning this has two possible real solutions, one being at +4 and the other being at -4. Number 2, it says what values of x makes the equation true. So first we have to isolate the square. So in this case, that square part is going to be this entire term here. So we have to get that part by itself first. So I'm going to add 3 over. So I get 3 times x plus 1 squared is equal to 12. Then I'm going to divide both sides by 3. And I get x plus 1 squared is equal to 4. I'm then going to undo the square by taking the square root of both sides, which means I'm left with x plus 1 is equal to +2, and x plus 1 is equal to -2. Because remember, when we are using the square root method to solve for quadratics, we always have two possible solutions. Because when we square a number, the negative goes away. So we know that there's always a positive version and a negative version. So because of that, I had my two equations. I'm then going to simplify for x and each one separately. So I'm going to subtract 1 and I get x is equal to 1. And I'm going to subtract 1 on the other side and I get x is equal to -3. Which means that this equation has two possible roots, which is 1 and -3. Okay, example 3. What is the solution to this equation? So again, we're trying to find our square value, our square term, and that is that 3x plus 2 squared. We need to isolate that. Okay, so for here, we are going to divide both sides by 7. So I have -336 divided by 7. So that gives me -48. So I have parentheses 3x plus 2 squared is equal to -48. I'm then going to take the square root of both sides to cancel out the square. But notice here, if I take the square root of a negative number, I know that does not exist, which means my root is going to be imaginary. So when I do that, I have, let's see, I have 3, let me change the color. 3x plus 2 is equal to the square root of 48i. Okay, so remember that this square root of negative 48 is the same as writing the square root of 48 times the square root of negative 1, which this is the same as saying the square root of 48 times I. Okay. Off to the side, we are going to try to simplify that radical square root of 48. We can simplify this by using the prime factor tree. So again, this is a skill that you learned in Algebra 1. So if you don't remember, I would go back and try to relearn that skill. So a prime factor tree means we take our number and we divide only by prime numbers. So 48, I'm going to start with 2. 2 is a prime number. 48 divided by 2 is 24. And then 2 divided into 24 is 12. 2 divided into 12 is 6. 2 divided into 6 is 3. I stop at 3 because 3 is also prime. Then I circle pairs of 2. So I have 2 pairs of 2, which means that the square root of 48 can be simplified to 2 times 2 square roots of 3, which is the same as saying 4 square roots of 3. Okay, so I have 3x plus 2 is equal to 4i square roots of 3. Okay, I'm then going to subtract 2 to both sides, and I get 3x is equal to 4i square roots of 3 minus 2. They're different terms, so we can't combine them. And then lastly, I'm going to divide by 3, and I get x is equal to 4/3. Let's see, how can I write this? Let's do it all just divided by 3. 4i square roots of 3 minus 2 divided by 3. Okay. And remember, when we take the square root, I always get a positive and negative version of this. So this is going to be x is equal to plus or minus 4i times the square root of 3 minus 2, all divided by 3. I'm going to put that 3 in the middle here. Okay, so that means that the solution to this type of problem is imaginary. So this has no real roots, only imaginary. Okay, number 4 says determine the zeros of the quadratic function. So remember, first we have to get the x squared value by itself. So I'm going to add 5. Oops. I'm going to add 5 to the other side. Okay. And we know that that f of x value, which is the same as saying y, is going to be 0. Because if we're finding the zeros, that means we're crossing the x-axis. And when we cross the x-axis, y is equal to 0. So that means I'm left with 5 is equal to 2/5 x squared. In order to get rid of that 2/5, I'm going to multiply by the reciprocal 5/2 on both sides, which means I have 25/2 is equal to x squared. I'm going to take the square root of both sides to cancel out that square, which means I get x is equal to plus or minus. The square root of 25 is 5, and then the square root of 2 stays the same, and that is my answer. Okay, number 5 says what are the x-intercepts for the quadratic function given by the equation below? Again, we know that g of x is the same as saying y, and we know y has to be 0 in order to find the x-intercepts. So I have 0 is equal to 2/3 x minus 4 squared minus 6. I need to isolate the square part, so I'm going to add 6 to both sides, and I get 6 is equal to 2/3 x minus 4 squared. In order to get rid of the 2/3, I'm going to multiply both sides by the reciprocal 3/2. Okay. Which means I am left with 18/2, which is 9. So 9 is equal to x minus 4 squared. I'm going to square root both sides to get rid of that square. And I get x minus 4 is equal to plus or minus 3. Okay, so that means I have x minus 4 is equal to 3, and x minus 4 is equal to negative 3. So if I simplify each one and solve for x, I get x is equal to 7, and x is equal to 1. Number 6 says the square below has an area of 27. Use this to answer the following questions. It says, what is the exact value of x? So we know that the area of a square, the equation is side square equals the area. Okay, so our side is that 2x minus 1. So I have 2x minus 1 squared is equal to 27. Okay, which means in order to solve for x, we have to take the square root of both sides. Okay, and so I'm left with 2x minus 1 is equal to plus or minus the square root of 27. Okay, since we can't take the square root of 27, we have to simplify that radical by doing the prime factor tree. So off to the side, do the square root of 27, and I'm going to divide all the prime numbers that can go in it. So that's 3, which gives us 9, and then 3 and 3. And then I know that I can stop because I end with a prime number. I circle my pairs of 2, which means that the square root of 27 is the same as 3 square roots of 3. So I'm going to write that there. So 2x minus 1 is equal to positive 3 square roots of 3. And 2x minus 1 is equal to negative 3 square roots of 3. Okay, then I'm going to add 1 to the other side. So I get 2x is equal to 3 square roots of 3 plus 1. And then divide by 2, so x is equal to 3 square roots of 3 plus 1 divided by 2. And then the same with the other side. So I have 2x is equal to negative 3 square roots of 3 plus 1. And then x is equal to negative 3 square roots of 3 plus 1 divided by 2. Okay, so I have my answers here and here. But what I'm going to do is I'm going to plug this into my calculator to give me the exact value of x. So I have 3 square roots times 3. Okay, plus 1 divided by 2. So this first value here, I get x is equal to 3.098. And then the other one, so I have negative 3 square roots of 3, so 3 square roots times negative 3, okay, plus 1 divided by 2, okay, and this gives me negative 2.098. Okay, so based off of these two values of x, we can only choose one to find the exact value of x. So what that means is that if we are talking about the area of a square, we are measuring the distance of every side. So since distance can only be positive, that means our x value is equal to 3.098. Okay, it cannot be the negative one because we cannot have a negative distance when we measure. Okay. Part B says, what is the approximate value of x to the nearest thousands? Okay, we already did that part by putting it into our calculator. So we got x is equal to 3 square roots of 3 plus 1 over 2. And after putting it in our calculator, we got x is equal to 3.098. And does it give us any units? No, so I'm just going to put units since it doesn't give us any. Okay, part C says, what is the approximate side length of the square to the nearest thousands? So remember, our side length of our square was 2x minus 1. So I have 2x minus 1, but instead of x, I'm going to put that 3.098. So 2 times 3.098 minus 1. So 2 times 3.098 minus 1 gives me 5.196 units. Okay, so that means one side of that square is about 5.196 units, meaning if we took that value and squared it, and you can do that on your calculator, if you take that value and you square it, 1 minute, I'm trying to type it in. Squared, you should get really close to the area of 27. So again, if we took that number 5.198 and we know that the area of a square is s squared, we get that the area is equal to 5.196 squared, which gives us 26.998. And if we go back up to our original value, it says that our area is 27, and we got 26.998, which is a very good approximation for the area, which means we found the approximate side length of the square.